All right, let's get started. Good afternoon, everyone. This is one of the last sessions of the conference, so I will try to make it as least boring as possible and hopefully useful for you guys. So we're going to talk about containers and container monitoring troubleshooting. I will try to focus a bit on data-based applications and also orchestration infrastructures like Kubernetes, Mesos, and so on. My name is Degioanni. I'm the creator and CEO of Sysdig. Sysdig is both an open source project and the company behind the project. I have a pretty long history in open source and performance monitoring. In particular, this is my second company. My first company was the company behind a pretty well-known network analyzer called Wireshark. And Sysdig tends to draw quite a bit of concepts from Wireshark. So if any of you is familiar with Wireshark, the tool should look, with some common concepts that you're used to. How many of you are using containers? Who's not using containers? Let's see who wasn't listening to my question. And just to tune my presentation, how many of you have heard about Sysdig? Oh, quite a bit. So containers are great, no question on that. They are, really changing the way we develop, we deploy, we maintain our software. They bring a lot of benefits: less overhead, faster deployments, reproducibility of environments, cost optimization, isolation, flexibility. These are just examples. There's much more than that. On the other hand, inspecting containers, monitoring them, having visibility in them, tends to be not completely trivial. In particular, containers are isolated, self-contained, simple, lightweight. These are all features that we love, but that also make monitoring and troubleshooting a bit harder when we're using containers. So, the question that I used to start Sysdig as a project, and especially the container and microservice support in Sysdig, is can monitoring actually respect these properties? So can monitoring not only, let's say, become at par with what we were used before, but can maybe also become a bit better thanks to these properties? And monitoring is not all of it, right? It's great to gain visibility into our containerized and microservice-based and orchestrated infrastructures. But then, the last mile, the final step, actually isolating the issue and maybe fixing it, becomes even more complicated. So there's a bunch of questions that are not easy to answer. So in a configuration like this, where your container ship is sinking, ideally you don't want to be this guy, sitting at a chair and not being able to see what's inside. So let me start with a bit of context. So I'm starting from the traditional model of virtualization. So we have, this is of course very simplified, forgive me. It's just for the sake, of giving a bit of context. We typically have, with virtual machines like VMware or Xen or whatever, a hypervisor that acts as a layer between the hardware and the running software. And then we have a bunch of virtual machines sitting on top of the hypervisor and being able to share the same piece of hardware. Typically, in an environment like this, there are a couple of places where we can interject our monitoring. One is the hypervisor itself. So this is nice because it's very horizontal, supports everything. It's, of course, application agnostic because it doesn't matter what's running inside the virtual machines. On the other hand, the limitation of this approach is that it's very shallow, right? When you are at the hypervisor level, yes, you can instrument everything very easily, but typically what you see for each virtual machine is just CPU, memory, and disk, and not much more than that, let's say, in typical cases. So it's a bit limited as an approach. So in the virtualized world, pretty much people standardized on putting agents inside each of the virtual machines, right? And these agents can be multiple things, from libraries that you link to your applications, to local little processes, to daemons, but essentially being able to run inside the operating system gives these agents much deeper visibility and much more granularity into the actual application and the actual processes running inside the virtual machines. So fast forward to containers. Now what we have is the operating system is the entity that acts as a mediator for hardware access, and is a bit the equivalent of what the hypervisor was before. And we have a bunch of containers run on top of that. So one approach is, again, putting a monitor agent inside each of the containers, and this essentially gives us parity in terms of visibility and granularity with what we had before with the virtual machines, right? The problem is that this doesn't work. This doesn't work for a number of reasons. I'm mentioning something here, but it doesn't scale. Typically with the containers, the density is much higher and the size of the containers is much smaller. So adding, not only another process, but all of the dependencies like Python, Ruby, or whatever you need to to run your monitoring scripts typically makes the sizes of containers much bigger and makes them much heavier. So it sort of kills some of the benefits of containers. It's not composable, so you cannot just get a container from the Docker Hub and use it. Adds dependencies, and then actually Docker sort of recommends you just run one container per machine. One process per container. So adding the monitoring agent not only doesn't work very well, but it's actually discouraged by Docker. So what else can we do? One possibility is doing sort of the equivalent of hypervisor level visibility, right? So putting a module inside the kernel and sitting essentially underneath the containers and being able to extract some data from there. Now, the benefit with this approach with regards to containers is that what is typically considered an issue with containers, which is the relatively limited isolation of containers, can also be leveraged as a feature, as an advantage when you want to do monitoring. So it's possible to have a monitoring container that sort of gains visibility inside the other containers, but in a way that is much deeper and much more powerful than what you could do with a hypervisor level visibility in the past. So going back to the guy watching the container ship sinking, it's a bit like giving superpower, like X-ray view to the guy so that it's able to see inside these containers by sitting on his chair, which is pretty cool, right? What else would you want better than this? Maybe a beer. This is what Sysdig tries to do. Sysdig is an open source tool. It captures system events, filters them, and then you can use it to run useful scripts on top of it. Sysdig, I often compare it. I will show quite a bit of it during the second part of the demo, but to give you an idea, a high-level idea of what Sysdig is, I typically compare it to strace plus TCP dump plus LSOF plus HTOP plus Lua. Now you're probably even more confused than before. But it's just all of these tools put together in a way that is, let's say, tries to get the best out of all of these tools. It's open source, as I said. It has a nice curses UI, so command line UI. Sysdig is designed to be production ready, so ideally you should be able to run it on production machines. Other tools, for example, like strace, typically produce a lot of overhead, so it's typically suggested not to use them on production machines because they slow them down quite a bit, while Sysdig is designed to be used for production troubleshooting, so simple and lightweight. At the same time, the data set is very rich and is designed to be consumed in a pretty elegant and easy way. Sysdig has native support for containers, and we also recently added native support for orchestration technologies like Kubernetes, like Mesos, like Docker Swarm, and so on. From the architecture point of view, essentially what you get is, this is your kernel again, and these are your containers, or also applications, running on the machine on top of the kernel. So what happens is we use a little kernel module that is injected in the operating system. Typically, when you use Sysdig from inside the container, you are not exposed to this because the container has all of the logic to do this when the container starts. But the little kernel module is able to capture all of the information that the different containers are exchanging with the operating system. And so it's essentially everything that an application is doing. It's networking, it's storage, it's file I/O, it's inter-process communication, it's the creation of new threads or new processes. So everything goes through the red circles. This data is captured by the kernel module. It's consumed by the Sysdig container, and then it can be used for live analysis, or it can be dumped to a trace file, a bit like what you do with TCP dump and Wireshark, so that you have essentially the file that represents the activity of a machine, and you can take it off the machine, and you can share it with somebody else or analyze it later. Stopping for a second, questions? All well? So let's jump to a real operating system, and let's take a look at what Sysdig can do for you. So the simplest possible thing that you can do is run it without any command line argument, and you get a beautiful screen full of system events. So what we're seeing here is system calls, signals, memory allocations, processes spawning, all of this kind of stuff. So it's a bit like a glorified S-trace, right? And this is the end of the demo. Thank you. I showed you this because this is the core information that Sysdig captures. Typically, you don't leverage Sysdig at this level. As you can see, it tends to be too much information. The first thing that you can do with Sysdig is apply filters. So I can run the same command line, but I can do something like event.type equal open. And essentially what we're seeing now is only the file opens that are happening in the system. So as you can see, much less activity. And Sysdig has a full filtering system that is very similar to the Wireshark or TCP dump one. So you can create pretty elaborate filters that act not only like on the system call type, but on the name of the file, the directory, the tuple, if you want to filter on network activity, and a bunch of stuff like that. Still pretty technical. Great for troubleshooting. But let's maybe talk a bit about containers, and let's move to Sysdig, which is the command line interface for Sysdig. Actually, before going into Sysdig, containers, you can sort of look at the processes that are running inside containers from the host, because these are just regular processes that run inside their own namespace and C group. But like if you do top, your container processes, and if you do top from the host machine, your container processes are here. The problem is that top doesn't have any kind of context of what's inside the container or what's not, just gives you a long list. So one thing that you can do with top, for example, you can add a field like C groups. And you see now this last column is essentially the C group. So two processes that match the same string here live in the same container, which sort of helps you, but it's, as you can see, not very friendly. Sysdig, on the other hand, can understand containers natively. So, by the way, here now I'm operating on a trace file. Sysdig, of course, can run live. So again, I run it without any kind of command line argument, and I'm seeing an interface that is similar to top. Actually, it's very similar to HTOP. I love HTOP. It's one of my favorite tools. So when we started building these, I wanted to mimic the user interface, including the key combinations, so that you are as familiar as possible if you're using a tool like HTOP. But here what I can do is I can open a trace file, and let's do this. And as you can see, now I'm analyzing a machine without sitting in front of the machine. And as you can see, I'm seeing a list of processes very similar to what I see with Top and HTOP. So nothing very revolutionary here, but I have a container column that I can also use, for sorting, so that I can see, there's several WordPress containers on this machine. There's a MySQL container, and then there's a bunch of stuff running inside the host. So a tiny bit of context. On the other hand, a tool like Sysdig has a couple of features that you don't have in your typical Top or HTOP. One of these is the concept of views. So right now we're looking at the processes view, which is the basic view and it's the starting one. On the other hand, I can click on F2 or click on views here, and I present it with a list of things that I can see for this machine, in particular for this trace file. So for example, I can pick something like containers. And now we are seeing the list of containers that are running inside this machine. As you can see, 4 WordPress containers, a MySQL container, an HAProxy container, and a client container. Another feature that I have here that I don't have in my typical Top program is the ability to drill down. So I can move up and down in my selection. I can click on a line, for example, MySQL, and now I'm inside MySQL. And I'm seeing the processes running inside this container, only MySQL. I can keep going. I click again, and I'm seeing the threads that MySQL is running. And of course, I can go back. I click on the back button on my keyboard, and I'm back to the container. So now I'm inside the container. I still have the ability to change my view. So now I'm looking at my processes view, but I can do something like, I don't know, directories. And this container is only writing to /tmp. I can drill down inside it, click enter, and I'm seeing which files are read and written inside this container. I can go even deeper. Another feature that I have here, 2 things. One is called echo, and the other one is called dig. So echo, you access it with the F5 key. And let me do the other selection. And essentially, what this does is, based on the selection that I had, so a specific file, this shows me all of the buffers that have been read and written to this file. So let me do it again. And as you can see, this is a temp file, so not very interesting stuff, but I can actually inspect into the data that is being read and written, for example, by my database in this case. I can also use the F6 key, which is the equivalent for dig. And here I'm seeing the specific system calls for this file. So I'm seeing, that it's open. I'm seeing the writes. And each of them, is timestamped with a nanosecond granularity. So I'm actually following, the file activity on a specific file. Here the file is closed, then it's opened again, and so on. So I was able to go from the full machine into a specific container to the details of a specific file, to actually the buffers or even the single operations of the single file. So again, when you're troubleshooting things, this is pretty powerful, especially considering that the alternative with containers is really limited, especially because containers tend to be small. As you can see, this container is just running one process, and typically they don't have all of the tools that you're used to, you need to install them separately if you want to do this kind of troubleshooting. So having access to this kind of visibility from outside the container prevents you from having to install stuff inside the container just to get this kind of visibility. All right, stopping again for a second to see if anybody has questions. All right, keep going. Let me go back to my whole machine, and let me pick, for example, one of the WordPress containers. Now I'm inside. I'm seeing, the Apache 2 process. One thing that I can do here is pick a view like server ports. And I'm seeing that this container is generating traffic on 2 different ports. Port 80 and port 3306. You guys are familiar probably with port 3306. Actually, let's pick port 80 first. And again, let's read down. So let's click enter. And these are the connections made on this port. I can pick one, a random one, and again, I can echo it. And now I'm seeing my HTTP traffic. This is, a WordPress server that is receiving requests and then doing queries to MySQL and then returning the request. So these are requests with the header and everything else and the response. And I can see, for example, this one is a 302. I can see the status code and a bunch of stuff like that. But I can also go to the connections on port 3306, and these are MySQL, so I can do the same. And now I'm following the MySQL protocol. So as you can see, I can actually see the queries that are performed to MySQL. Again, the beauty of this is I'm seeing the queries by sitting outside the container. Actually, I'm looking at the queries from the vantage point of the WordPress container. So not even from the MySQL container. Of course, I could go to the MySQL container and look at the queries from back there. And again, even here, I can dig inside it. And at this point, I have, all of the specific details, the connect, call. This is, the WordPress process playing with the socket, and then the data is sent and received. And then at the end, I will have, the close on the socket. So the whole sequence of activity for this specific connection between WordPress and MySQL by sitting outside and capturing these from the host and in a trace file. One more thing. I'm going back to the full machine. At this time, what I'm going to do is I'm applying a view called errors. So what this does is this view intercepts all of the calls to the operating system and then categorizes them by return code. So and resolves these return codes so that I can see, how many I/O errors have been done inside this machine. And again, this is categorized by essentially the Linux code. And the first one, I have 3,000 of them. InnoEnt is file not found. So I can click on it, and now I'm seeing the processes that are generating these errors. The first one, by the way, is called API server. So again, one thing that I can do is dig on it, so F6. And now I'm seeing the single calls that are generating this error made by that process. And I can clearly see, that these are all open calls, and they are trying to open this file. This is the full path, and the open fails. So either this full or some kind of writes on the directory, or maybe the directory doesn't exist. But at this point, it's pretty easy to identify the problem. One more thing. If I go back to the full machine and I pick containers again, one cool feature that we added to this, and to remind you, this is a console-based interface, but we created this sort of neat representation, graphical representation that we call Spectrogram. For example, let me do it for one of the WordPress containers. I do it by clicking on F12. So what is this? The horizontal axis is time. And is the time taken by calls to the operating system to return. So essentially the latency when you're running whatever, your MySQL when you're running anything. So it's opening files, creating connections, and so on. This is sort of an overview of how long these things take. Every single horizontal line is half a second, and the color of these boxes means that there's activity at that specific latency, and the stronger the color, the more activity. So we can see, for example, that this is a typical pattern. This is the MySQL container, I believe, and no, this is a WordPress container. So typically, what you see is stuff on the right. This one, by the way, is exactly 1 second. So typically, these are callbacks or stuff like that, right? While the bulk of the activity typically is much faster. This is your I/O, your network, and stuff like that. So for example, if we look at the MySQL one, we can clearly see, straight lines here, and the bulk of the activity here is here. So if I pick the straight lines, by the way, one thing that I can do is with my mouse, I can highlight a portion, and I create a filter for a drill down, right? So now I'm drilling down only in the events that are inside this box, right? So I click, and I clicked on the 1 second area, and as you can see, these are selects, all made by MySQL D, selects and events and the kind of stuff. While if I go, to the core where there's more activity, like in the microsecond level, these are all reads and writes to files. This is actually network. There's a bunch of network stuff, and there's a bunch of stuff on temporary files. So it's a bit like a summary of what your container or your process or whatever, because you can apply this to anything that is selected in Sysdig. In particular, for example, I can quickly visually compare the different WordPress containers, and I see that they sort of look the same. So it's a visual way to find outliers if I have multiple containers and I'm concerned that one of them is showing some kind of degradation compared to the other ones. All right. Back to the presentation. This is great, but things are becoming more complex. So this beautiful and very elegant slide is my artistic attempt at showing, a monolithic application with 3 components, a cache, a web server, and a database, right? This is how things used to look like. Now they are a bit more like this, You have services that can implement many things, that can implement, load balancing, can implement computation, they can implement whatever, storage. And they are scattered across multiple machines. And typically you have orchestrators like Kubernetes, like Mesos, like Docker Swarm that just move this kind of stuff across machines based on their decisions, their algorithms, based on what's best in terms of resource utilization. So the problem is a single service could be scattered, across multiple containers. So there are 2 problems here. One is, how do we get the data out? And this is what I showed you up to this point. So the Sysdig technology can help get the data out of these containers. But problem number 2 is, how do you make sense of this data? Because seeing the data on a container-by-container basis typically doesn't make a lot of sense. What you want is the response time of your MySQL deployment that is scattered, across multiple machines. So there must be a way to put this kind of stuff together. So the idea is, how do you avoid essentially being in the orchestrated version of this? Everything is talking to everything else, and you have sort of a clusterfuck, and you can trace where stuff is. So let me switch again to the demo, and this time let's open a Kubernetes file. So I'm analyzing a trace file that I took on a machine that was part of a Kubernetes cluster. So let's go to views again, and let's open containers. Much less straightforward than the previous one, right? I can sort of see that there's a WordPress. It's a similar thing, So I can see again there's MySQL. Yeah, you see MySQL is here. So the stuff is there. But as you can see, much more complex because there's a layer on top of this. There's Kubernetes on top of this. So what we've done is we've integrated Sysdig with Kubernetes in a way that Sysdig is able to poll the Kubernetes API when it captures data. Kubernetes exposes a very nice API that gives sort of information about the structure of the cluster, namespaces, services, replication controllers, and so on. Sysdig is able to consume this information, put it together with the system data that it captures to offer a view that sort of merges the 2 together. So I have also new views here. One of them, for example, is Kubernetes namespaces. So now I'm seeing that this specific machine is running containers that belong to 2 different namespaces. Let's pick the one called Loris. And now I'm inside, and I can see the pods that are running inside this namespace. And I can see again that there's a MySQL one. I can, drill down inside it, and I'm, again, inside the MySQL process. So I have, and I can do the same investigation that I was doing before, but I can start it in a logical way that reestablishes essentially the hierarchy of the different services and namespaces that I'm running on these machines. Let me show the same thing to you, but in a web browser. This is Sysdig Cloud, and it's our software as a service product. So I'm, the trace file that I had on the screen a second ago was showing one of the machines in a 4-machine Kubernetes cluster. Sysdig Cloud is able to run the same instrumentation on all of the machines, take this data, pipe it to a centralized server that can live in the cloud or on-prem, and then put this data to have sort of the next level, As you can see, I still have a table, but this time I have the different machines inside this table. Now, I want to show you a couple of things here. One is here, we have the different machines, and I can expand one of them, and I can go inside it and, I don't know, look at something like the CPU utilization, and now I'm starting having, like pretty charts that I can, that are comparable with the ones of any other monitoring tool. But the place where this becomes a bit more powerful is when I change my grouping and adapt it to the Kubernetes hierarchy. So remove the physical machines and think in terms of namespaces and replication controllers and so on. When I do this, as you can see, I'm starting seeing the services, the namespaces and the services that are running in this cluster. For example, I can expand my production one, and now it's pretty easy to identify the MySQL one. So I have, a MySQL service in this cluster that is orchestrated by Kubernetes. And what I can do is, I can look at basic properties of these, but I can also go to views and type MySQL. And now I'm getting stuff like number of requests, errors, response time, top queries, the top tables in terms of number of requests, and in terms of response time, type of request over time, so select versus set, and so on. So how does this work? This data is gathered by using the technology that I showed you before. The MySQL container is doing system calls. Some of the system calls are socket system calls. Socket system calls, some of the socket system calls are MySQL requests that the server is serving. We capture these calls, and I was showing them to you like on a screen before while scrolling as text. But what we do here is we take them, we decode them, and then we pipe them to the backend so that, again, by just deploying the Sysdig agent, we're able to see into a MySQL that is running into a separate container, decode the network traffic, and then show, MySQL metrics for a separate container. One more thing here. If I go to dashboards, actually, this is what I sometimes, let me refresh the screen at this resolution. What sometimes I compare to Google Maps for your infrastructure. So we're seeing the same topology, the same 4-machine Kubernetes cluster that we were observing as a table in the previous page, but this time we're looking at it as a topology map. Since this instrumentation technology sits inside the containers and can capture every single connection that every container is doing, what we do is we store them and create a real-time topology map. So that, for example, here I have 4 machines, and I can start zooming inside one of them, and I start seeing the containers running inside the machine, and then I can go, even deeper, and I can look at the processes like Tomcat or MySQL that are running inside these specific machines. So, for example, this one is MySQL. Nice, useful, but again, orchestration sort of creates the spaghetti thing that I was showing before, Everything is connected to everything else. So a much better way to look at the same thing is grouping things in a semantic way. So this time I'm grouping by Kubernetes namespace and replication controller. And for example, I can see again, the dev and the prod environments. Let me zoom inside the prod one and look how cleaner it is, Two services, a WordPress one that is talking to MySQL, and a Java application that is talking to Cassandra, Mongo, and Redis. Exactly the same thing that I had before, just a cleaner and more straightforward representation of my data and my relationships. Okay, just another 5 minutes to mention one more thing. This is something that we haven't released yet, but I have a little experimental setup that I wanted to show you. So one interesting thing that you can do when you're capturing every single interaction between a container, a process, a thread, and the underlying kernel is you can sort of decode things that this application is doing and try to interpret, give them a meaning. In particular, for example, one thing that can be done you will be able to do with Sysdig is from inside your application, you write to dev null with a specific syntax. Dev null is available from anywhere, from your process, from a virtual machine, from a physical host, from inside a container. So anytime you can write to dev null, what we can do is we let you use a specific syntax, we capture it, because every write to dev null is like a write to the operating system. So nothing happens, but we capture it, we interpret it, and then from Sysdig we can do something. In particular, here, for example, I have a process that is doing, opening a file, then reading, writing, and then closing it. You can write to dev null what we call tracers. So tracers have tags, arguments, and so on, and you can use them to let Sysdig know that something is happening. Now, when you mark something with tracers inside your code or inside your scripts, because it's dev null, so you can do it from a bash script, what we do for you is we measure how long it takes in a hierarchical way, so you can nest these kind of tags. But we can also tell you what's happening inside. So, for example, how many files were written to file. Let me show you an example of this. Unfortunately, the font size here is... Can I do it this way? All right. I deployed a MongoDB instance running inside a container. I loaded it with a bunch of data, and then I ran these two Ruby scripts against this container. One does a loop doing a sequence of MapReduce, and the other one does a loop using the aggregate function of MongoDB. They extract the same data. They act on the same data set. They just do it in two different ways. Aggregate was included, I think, in MongoDB 2.2. So it's a more recent and ideally more efficient way to do this query with MongoDB. What you can do, as you can see, is I put a marker at the beginning and at the end of the query, and I just print them on standard output. And then I redirect the script to write standard output to /dev/null. This is the syntax that Sysdig understands. So you see the first character is enter and exit here, and then the name of the tracer here is aggregate, and the name of the tracer here is MapReduce. I ran these two scripts together, and then I saved the results in a trace file. So if I open the trace file, now I have a view that, for example, is a tracer summary. So as you can see, this view is showing me the two tracers that I put in my two scripts, aggregate and MapReduce. It shows me how many hits they do, and it shows me, what's their average time. And I can see that the aggregate is almost 10 times faster than MapReduce, 34 milliseconds versus 205 milliseconds. An even nicer way to see this is using the tracer spectrogram. So this is exactly what I showed you before, but instead of showing you the latency of the system calls, shows you the latency of the tracers that we've added to the two scripts. So I guess you guys can guess which one of these vertical lines is MapReduce and which one is aggregate. If you want the proof, we can again drill down. So pick a section of this one, and it's aggregate. And as you can see, 50, 60, 40, 30 milliseconds. So it's in the few tens of milliseconds for this query to return. And if we do the other one, it's all MapReduce, and you can see it's the best one is 187, and the worst one is 221 milliseconds. So it's a way to put all of this together in a way that helps you when you need to troubleshoot or baseline or just do capacity planning or stuff like that. That's it. We used around 40 minutes, so if you are interested, there's still space for a couple of questions. Otherwise, there's one.
What's a typical overhead for the agents for each container? And is that affected by how much you collect and how often you're collecting and emitting?
Yes, it's supported. So the question was, do we also support Rocket? And the answer is the beauty of the technology is that it sort of lives underneath the container runtime, right? So we reason in terms of C groups and namespaces. Then we do a bit of work to nicely decode, integrate with the Docker API and so on. But typically we support any containerization technology. And we actually did very recently also do the nice work to support Rocket, so you have all the nice names and so on. So we have support for all the major container runtimes. And there was another question here, right? Slides. Yeah. So the question is about the slides. Maybe, yes. I've given the slides. So I've given the slides to the conference organizer. So I'm assuming they will be there. Otherwise, there was my Twitter handle on slide number 1. Maybe since I don't have an email here, it's the first way to reach out to me for slides.
Is there an export to common monitoring tools like Null or
So currently not, but a couple of things. One is I didn't show it to you, but we have integration with Lua so that you can script the tool. And so creating this kind of integration is relatively easy because there's already all of the components in Sysdig. That's number one. Number two is the tracer functionality that I showed you is not released yet, but when we will release it, it will contain, it will include an exporter to Sysdig, and at the point it's Sysdig, so you can ingest it with whatever you want. And number three is we offer a commercial solution to solve this problem as well, which is Sysdig Cloud. No more questions? All right, thank you guys. And have a good afternoon.